Welcome back, children. We are going to start with a completely new chapter today, logarithms. Okay. As we have studied about the operators, logarithm is also an operating system. Let's see how we express logarithms along with the exponential forms. What we do is that let us consider a to be a positive rational number, real number, and n to be a rational number. And we can also write or express a to the power of n equal to b. If this is the case, that means if this is the case, that means if a is a positive real rational number, n is a rational number, and if a to the power of n is equal to b, then when we use the operator logarithms or log, we can write log of b to the base a is equal to n. Okay, what do we write? Log of b to the base a is equal to n. This is the logarithmic form and this is the exponential form. Okay. Now there are certain rules of logarithms. We're going to learn a very few in the first exercise and a few more when we start with the second exercise. So for the timing today, we are going to learn just a few rules that are required to solve the sums from the first exercise. Let's see what are those. First one, if the base and the number on which the log is operated, that means log of a to the base a, that means if these two are equal, then the value of log becomes equal to 1. Next, log base anything, whatever, but if the number on which the log is operated is 1, then the value becomes equal to 0. Third, if we have log base a x is equal to log base a y, okay, then we can write therefore x equal to y. Why can we write this? Very simple. We take that let log of x to the base a and log of y to the base a is equal to n. So when we are converting this in exponential forms, we can write a to the power of x is equal to, a to the power of n is equal to x, and this one a to the power of n is equal to y. So in both the cases, what do we see is this is also a to the power of n and this is also a to the power of n. So from here we can conclude that x is equal to y. Okay. Next one, common logarithms. Common logarithms are those logarithms whose base is always 10. We need not write the base for common logarithms, like say this is the thing which is given to us. No base is given. If no base is given, this is supposed to be taken as 10. This means log of a to the base 10 is equal to 5. Is it clear? Okay. So these are the few rules that you need to remember. Now let's begin with the exercise. EX.9.1. I'm going to show you just a few varieties of sum, and the remaining sums you are going to get it through the PDF. Question number 3. Here they have given the exponential form 7 to the power of x is equal to 100, and they have told you to express this in logarithmic forms. What can be written? 7 to the power of x equal to 100 means log of 100 to the base 7 is equal to x. Okay. Next, just the opposite one. Question number 2 is number 3. Here, log of 1 by 3 to the base 3 is equal to minus 1. That means this is the logarithmic form. They have told you to express or convert this in exponential form. Very simple. Here we can write 3 to the power of minus 1 is equal to 1 by 3. It's very simple a thing. Base to the power of this will be equal to the number on which the log is operated. Okay? Alright. Let's move on. So guys, suppose you have understood this. Let's move on to the next pattern of sums. Question number 3. I'm going to do number 2. It's given log 125 to the base of 5. They told you to find out the value with the help of exponential form. So this one I can write as equal to x. Okay, so when we are writing it in exponential form, what can we write? 5 to the power of x is equal to 125. Now 125 means 5 cube. Okay, now you see both the bases are equal. So since the bases are equal, therefore x is equal to 3. Okay, simple sum. I'm doing question number 3 is number 5. Log of 0.01 to the base 10. They told you to find the value of this. So again we are considering this to be equal to x. So what can we write? Therefore 10 to the power of x is equal to 0.01. Now 0.01 I can write it to be 1 by 100. Okay. Now 1 by 100 means 10 to the power of minus 2. Now see, once again both the bases are equal. So if the bases are equal, I can write therefore x is equal to minus 2. Is it clear? Okay. So let's move on to the next sums. Next sums are solving of the equations which are given to us. That's question number 4. I'm going to begin with question number 4's number 6. Simple sum. Log of 1 by 4 to the base x is equal to minus 1. Okay? And they have told us to solve for x. So from here, if you are writing it in exponential form, I can write x to the power of minus 1 is equal to 1 by 4. Alright? Now, 4 I can write to the power of minus 1. Why? Because 4 is in the reciprocal. All these laws and rules which I am applying, they have already been taught to you when you were taught with indices. Same rules and laws apply here. Okay? Now, you can tell me as to Miss, why did you apply 4 to the power of 1 instead of applying 2 to the power of minus 2? This is because if bases are equal and both the sides are equal, that means the powers will be equal. Just when we think in a very converse way, I mean that's the opposite way. If 2 sides of an equation is equal and the powers are equal, so definitely the bases will be equal. So from here I can write therefore x equal to 4. Clear? Okay. So let's move on. Let's move on to sum number 8. What do we have in sum number 8? Log of x to the base of 9 is equal to 2.5. One more simple sum. From here I can write 9 to the power of 2.5 is equal to x. Now 2.5 is a decimal. You have to express this in either fraction or in whole number. Now point can't be expressed in whole numbers. So what we will do? 2.5 can be written as 25 by 10. Okay? So I am getting 9 to the power of 5 by 2 is equal to x. Now 9 can be written as 3 square. So what do I have? X is equal to 3 to the power of 5, which is 243. Clear? Okay. So let's move on to the next sum. This one is also a sum from question number 4. I just wanted to show you one or two patterns from this type. That's why I am doing one more sum from here. That is sum number 15. What is given to us? Log of x square minus 1 to the base 2 is equal to 3. Just like the previous sums, we are going to do it. So in exponential form, we can write 2 to the power of 3 is equal to x square minus 1, or 8 is equal to x square minus 1, or x square is equal to 8 plus 1, that means 9. Okay? Or x is equal to root over 9, that means plus minus 3. I suppose all of you are aware of why this is plus minus 3, because square root of any number always comes with a plus or minus. Because when you square a number, it can either be a negative or a positive number, doesn't matter. Answer always comes in positive. So when you are square rooting a number, remember to keep a plus or minus in front of the answer. I suppose you understood this, sir. Okay? So let's move on to the next pattern of sums. I'm going to do sum number 5 for you. Let's see what is given. Given log a to the base 10 is equal to b, and I have told you to express 10 to the power of 2b minus 3 in terms of a. Simple sum. You have to just understand, rather you have to remember the laws of indices. First, let's convert this into exponential form. 10 to the power of b is equal to a. Okay? Now let's go back here. 10 to the power of 2b minus 3. Remember your indices. I can write 10 to the power of 2b into 10 to the power of minus 3. I can write it. Okay? Next, 10 to the power of b whole square by 10 to the power of minus 3 means by 1000.
I am broke and jobless because the coronavirus.
Okay? Now, 10 to the power of b, what do we have here? A. A square by 1000. Alright? Did you understand? This is also a very simple pattern of sums. In this exercise, the remaining sums will be of the same type. Okay? Alright? Let's move on to the next part. The last sum for today which I am going to show you is sum number 10. What what do we have in sum number 10? Log of y to the base 2 is equal to x. Log of z to the base 3 is equal to x once again. And they told you to find out 72 to the power of x in y and z. Simple sum. Okay. So when we write this in exponential form, this one can be written as 2 to the power of x is equal to y, and this one can be written as 3 to the power of x is equal to z. Alright. Now, when we prime factorize 72, I am not doing it, but when you prime factorize, you will find that 72 is actually 2 cube into 3 square. Okay? To the power of x. Now this can be written as, using the indices laws, 2 to the power of 3x, 3 to the power of 2x. Alright. Again, 2 to the power of x whole cube, 3 to the power of x whole square. Okay. So, what do we have? We have 2 to the power of x means y cube, and 3 to the power of x means z square. So, this is our answer which we require. So, when we express 72 to the power of x in terms of y and z, we get y cube into z square. Okay. So, children, that's all for today. We are going to continue with the next exercise in the next class. Thank you very much.